Hey guys, welcome to Data Networking. This is the first time I shared it through the web base, so let's go ahead and get started. So, networking module one, Professor Seaman. Um, so, our objectives for this lab for this or this lecture this week is what is networking. We're going to talk about communication process. We're going to identify what the OSI model is and how it relates to networking today. And then we're going to talk about the encapsulation of OSI models. Okay. So when you think about data networking, so what are the things that you think about when you see these two devices? What do they look like? Now, they may be a little archaic. They may look similar to you. Um, these might be these might be devices that you find in your house. So the one to the right looks like a cable modem. You know, a modem from Comcast, Xfinity, whatever it's called, a DSL modem. It could be a DSL modem from Verizon or whoever your provider is. It could be a fiber optic modem, but these devices are likely, in this case, are ISP related. So, to the one to your right model, that one that looks like probably the first cable modem that I had available to me, like back in 2001, 2002 timeframe from Xfinity, which was Comcast at the time. And well, that's the name they went by. And to the left looks more or less something that Verizon would provide from a DSL modem standpoint. So these are common things that you would find in your house. Now, they obviously look a little bit different now compared to before. When we move over to this slide and we talk about data networking. So this is something that things have changed gradually over the years, and this right here looks more or less like a wireless router. You know, the antennas on it, the little icons on the bottom there. This is a router that is typically allows your smartphone, iPhone, Android, tablets. You know, maybe you have a iPad, Android device, laptop, whatever to communicate to the internet. And it doesn't stop there. I mean, think of other things: your refrigerator, your television, your smart TV, your microwave, your dishwasher, your dryer. I mean, all these different things are smart in some way and utilize the internet and devices like this. Now, traditionally, these devices had antennas on it. Like when networking, when wireless networking came out, like like I say, early 2000s, they had these. I wish I had a device, but they had a small device about the size of this that plugged into your wall and it had a big antenna. And that's how you got internet. And then eventually, hopefully, I don't get disconnected here. It's starting to thunder and lightning in February. Really? Um, so, and watch me lose power. Knock on wood. So these devices here, the antennas and so forth, they were able to broadcast a signal out, and that whole functionality has changed to a degree where I don't see that being utilized as often as you would think. I wish I had a photo of my router. It doesn't even have anything like that anymore. So moving on. So moving on to data networking. This is when you look at this. What's the first thing you see? These are servers, basically switches. This is something obviously you don't see in your house unless you are me. You might have this in your closet. Um, it's a data center or a business networking closet. Um, Looks like a bunch of switches that has a lot of cables plugged into them. So you see the cables in the back there. If you count, I think there's probably 12 on each top. Yeah, if you look at, it's really hard to see, but looks like it's 1, 3, 5, 7, 9. Yeah, so it goes across the 24. So usually, in this case right here, it's all 24 ports, all Ethernet cables going into those ports. Those are considered switches. It can be a closet. So, like for example, take your high school building or your college building, and take we'll say floor number two. Closet has maybe I don't know. Depends on how many. It depends on the amount of devices on that floor. So that's how many switches are probably there. These are just cables connected there that connect to, if you ever look, if you have a high school room or a college room and you have a cable going into the device, the computer, the printer, whatever, it's probably coming from that closet that's on that floor. And so this information right here is starts there, and then in the back of the server, the switch that you don't see, there's a wire probably going down through some hole in the ceiling or in up the ceiling or down the floor, and it's going to a server room where it's hooking up to a server or communicating with a server in another building. So it varies. Um, Basically, this is a way to provide network connectivity. So that's what we're looking to do. So moving on, none of them look as pretty like this one. So some get a lot messier like this one. It looks like a bird's nest. It's all over the case. I know from personal experience. I worked as a IT director. I walked into a situation like this where that closet that we just visited didn't even have any network patch cables on it at all. And if they did, they were outdated. And then I walked into a server room that was just like this, where it was kind of impossible to identify where anything went. So it's important to have things um, as clean as possible because it makes the process and makes everything a lot easier. So just something to think about. Um, but in this case, it also provides some type of network activity to an office or so forth. All right, moving on. So this right here is a little icon of what I would consider a server. So looks like a little server. As we talk about data networking, as we facilitate through it, data networking is basically the transformation of information. Okay. Um, in this case right here, we have a server. It's typically connected to a network and holds data. What does that mean? So wow. I have a feeling bad things are going to happen while I'm recording this. I just seen a flash of lightning go by. So this might be a to be continued lecture. I have a bad feeling about that. Um, wow. Yeah, I don't know if you hear my house shaking. Holy shit. Sorry, excuse me. Holy heck. Um, yeah, I'm recording this live, and that was pretty bad. Anyways, I'm gonna try to continue. So first video is very exciting. So a server is where something happens. So it could be a data server, it could be a file server, it could be an email server, it could be a web server, like holds websites, whatever. It could be a number of different things. Okay, but more importantly, it holds some type of data. So, for example, here's my website that I use here at the university, and this is an example of a server. Can an app? So, like I mentioned, it could be one of the three: app, file, or mail server. So, let's say that I want to go on my laptop, my computer, my whatever, and type in a website. I want to type in I want to type in jseaman.it.pointpark.edu, or which reroutes to this website right here, and search for something. I connect to a network that represents, in this case right here, we'll say a cloud device. Um, so we hit the server and it pulls up the website. So if I do something like this, so we call this guy over here to the left the client. If you ever reference something called a client, it could be a PC, it could be a laptop, it could be a MacBook, whatever. So the client makes a call and says, "Hey, I want to pull up that website." So boom, we'll reference the cloud as maybe not so much a cloud platform, but we could reference it as it means it represents those switches that we talked about, and maybe routers, and routers connect to wires and fiber optics and wireless and so forth. So it's how you get to the internet, whether it's in your house, whether it's an office, whether it's a college or high school or wherever. Okay. So this kind of represents that whole feature. So stop there for a second. So going back to this, you make a call, so you go to your website, and we'll talk about this whole communication process in the next part, and we'll actually continue it as we progress as well. So moving on. So we're talking about the communication process. What is a communication process? You know, how does, think about this. Have you ever thought about, I pull up my phone and I go to an app or I go to a website, like, I pull up my phone and I'm like, okay, I go here and I go there. How's that work? How's it know to get from point A to point B? And that's kind of what we're going to talk about today. We're going to go old school and we're going to talk about mobile devices. We're going to talk about telephones. We're going to talk about how we talk to one another. Like, I got two phones here, right? I have this phone and that phone. How do these two phones talk to each other? We're going to talk about that in this next part. Okay, so, we talked about data networking. It's a system of hardware, which requires hardware, software, and protocols. And in order to move information from one device to another, you need the communication process. Okay, so let's get started. So look at this diagram here. We have this communication process. I'm going to pause this for a second. All right, I'm back. I had to check on stuff. All right, so communication process. So we have this person over here, Sally. We have Bob over here to the right. So Sally has a problem and she wants to talk to Bob. And how does she talk to Bob? And so in this correlation here, we have Sally, she's using her smartphone. Bob, he's using his smartphone. And up the top is these cell towers. So we're always texting. Normally in this day and age, we don't talk on the phone anymore. We just text. Early on, when you get your first cell phone, you just call everybody. And I mean, we do that still, but mainly we text. That's the form of communication that we have going on. So we're texting our friends. We often, we do call them from time to time. But let's say in this example here, we have Sally on our left who wants to call her friend Bob on the right, and all sorts of processes that are happening here to make this happen. And so that's what we're going to talk about today is how does this happen? Do you know how when you actually call somebody, you call your mom, you call your dad, you call your sibling, how does it work? Well, that's a great question. So first thing you do is you go on your smartphone. You find that contact. In this case here, allows Sally on her phone to find, okay, guess what? I found Bob. He's in my contacts. Great. Allows her to dial Bob, phone the answer, and he says hello, and she starts talking. So we'll talk about what is that process, okay? So how does that work? So let's go to the next slide. All right, so great question. So Sally is going to start talking. What is going to happen is her phone is going to vibrate the air. So the air, the air that's happening right now. So I'm on this call and I'm like, hey, Bob, what's happening? Or, whatever. The vibrating air that carries her voice, if Bob was sitting right next to her, he would just be able to sit and listen to the air vibrate. Does that make sense? Just in his own eardrum. So if Bob was over here, he would be able to hear it. It's normal. No need for equipment. So since he's on the other side of the phone, Sally's voice is going to vibrate her microphone. So the microphone's in the phone here. It's going to vibrate it. And there's a little membrane in the phone. And this will vibrate the membrane, which is going to create an electrical signal inside the phone. So now it creates this electrical signal in the phone. And the phone will take this signal and convert it into a wireless signal, kind of like what's happening here in this diagram. So it's her voice is echoing in the diagram. The membrane is converting it, creating the signal, and then taking that signal and converting it into a wireless signal. So it's like your computer. When you type something in a computer, we know ABC, but it converts it into numeric values, zeros and ones. And that's what's happening here. Converts it to a wireless signal, as we see here, and then it sends it up to the cell tower, whichever your local cell tower is. And the next cell tower will take that signal and it needs to convert it as well because it needs to put it in another format that it understands. So it takes the wireless signal and converts it again. So it's converting and converting. So now what happens is you take Sally's voice, which was encoded in a wireless signal. So now it's been encoded as something else. The encoded voice then is going to translate the signal and now it can travel across these, we'll say, phone lines, an example, on the telephone poles. And these could be fiber optic. So think about the way that you communicating with another person. It could be copper. We can also send a signal from one tower to the next tower over the system. So the next cell tower that is maybe closest to Bob's phone, wherever that is, will then have to take that and convert that signal that came over the wire back to the wireless signal. So think about all the stuff that's happening here. You know, her ear is vibrating, the air is vibrating her voice. It's creating an electrical signal. That electrical signal is, sending it to the cell tower. It's converting it. Cell tower is converting it to another signal. It's communicating it. So it's a lot of converging back and forth. All these things have to happen. So it's almost like the perfect storm. So it converts it back to a wireless signal and then sends it down to Bob's phone. This signal is translated into Bob's phone into electrical pulses that vibrates the membrane of the speaker. So it's almost, we're going backwards of what Sally did. So the membrane then vibrates the air, and then Bob can hear those vibrations that Sally's voice is asking for help or whatever Sally is asking for. So think about that process for a second. Think about how that works. That is actually absolutely amazing how the voice and how the phone works and how it captures that information and sends it from tower to tower. Like, that's incredible. As I talk, I lose my voice. All right, so let's go on to the next slide. I'm probably slides away because I start talking and yeah, like this is the part where he's receiving the vibration. So like I said, I'm a slide behind because I start talking. And this is the part where the membrane is vibrating the air, and now Bob is able to hear the vibrations from Sally's voice asking for assistance. So we're going to go side model next. So conclusion of this, just think about when you're using your cell phone, your mobile phone, your smartphone, it's a constant process of translating our messages from one type of signal to another type of signal. And whatever is losing the data, we're trying to send. So think about when you're trying to call somebody and you're like, you're kind of, think about this. You're calling somebody and they're talking like a robot. So now you kind of have an idea of what's happening here. Why are they talking like a robot? Somewhere in between that translation, that signal got lost. And was it in between? Was it in the conversion part of it? That's cool. So now you kind of have an idea of what's happening. Okay. Well, that is the communication process. So hopefully that was cool and fun, a learning experience. All right. Let's talk about the OSI model. So what is the OSI model? We're going to talk about what that is and some more information around it. But it basically is an open systems interconnect. I'm hoping I get through this video before this dies. Communication between entities are split into smaller units of measurements. And that's kind of what we're going to talk about. And that's what we have to follow here. So in this example here, we have the client who's communicating with the router or the medium inside and is communicating to the internet. So protocols that have to happen to take place. So if we go to the next slide, we'll see another one where client communicates to the wireless router, then it communicates to the modem, cable modem, and then hits the internet. And now at the bottom, all the other things are happening, the same thing. Lastly, it's connecting to a server somewhere, a web server, whatever. So it's, this client communicates with a wireless router, then the router connects to the local router, which is the cable modem, the DSL modem, whatever, and it funnels through the internet and to a server, and the server is asking for a website, and it's received, and blah blah blah. So it's all this stuff is happening, kind of like the communication process, if you recall. So let's go on to the next slide. Same thing is happening here. We showed the cables, and now up to the top left is we're pulling up my website that we wanted to access. Okay, so in this case right here, I guess we could do it from here. Is there's no technology in the devices. We do have Ethernet input to allow cables to connect to the devices, and that covers the protocol. So there's no technology, no software happening that's allowing us to do this. And this is just basically this is the physical layer. Physical layer is, and this will be part of your homework assignment for the week, is defining this information. Your physical layer is your physical products at home. So think about products that you might have in place at home, such as your router, your cable modem, and so forth. So that would be your physical layer. That's the information that is actually having the data transfer through. So in this example, this is our physical layer. I think I went too far. Yeah. So then we have the data link layer. So what is the data link layer? These are protocols that are used to transmit information across. So if you look in the diagram here, you'll see that things are being transferred over from point A to point B. It's kind of getting lost. So protocols in this case are allowing us to transmit information over cables. It could be wireless, so it could be Ethernet, transfer data from one device to the next device. It could be DOCSIS. It could be Ethernet protocols. It could be wireless protocols. As you see, a lot of things are happening here. And this is, so physical layer is the equipment. Data link layer is the transferring of information. Just what I'm doing right here. I'm recording this video. I'm recording it live. Well, not live, but on a web browser. And this is communication aspect of it. Data link layer. So that's layer number 2 of the OSI model. So we have physical layer and we have the data link layer. Now we go to the third layer, which is actually layer 3. It's a network layer. This network layer allows us to send data far away to communicate between PC and cable modem, and then out of the internet, and then a way to communicate to a website outside the internet. So, for example, think about this case right here. So, think about this. If you go to a website it's in Australia, how are you going to do that? Network layer is going to allow you to access that because you're going to an internet. You're going to the internet. The internet has IP addresses that we're going to talk about later in upcoming modules. But it's a way for us to get out and communicate at a different level. Same thing is like use WhatsApp app on your phone. So if you're calling somebody internationally, so I have a friend who lives in Barcelona, or I have a friend who lives in Argentina. If I want to communicate with them, I'm going to use that over the internet versus calling them and getting a long distance international rate. So in this case right here, network layer is use of internet protocol, IP address, allows us to communicate with any device on the internet. Okay, so that's your network layer. Now we talk about our session layer, which is layer number 4. So if you remember how Sally and Bob had a conversation, Sally called Bob and he answered and responded. Well, this is called the Transmission Control Protocol, also known as TCP. This is the session layer that allows us to create a session. So it's like anytime you log onto a website and you had to enter a username and password in, that is creating a session. You're creating a session. And from a networking standpoint, this is creating a session in between those communications. Think about when you're watching television. You pull up the news, or you're watching a sports cast. You're watching the Steelers, the Pirates, the Penguins, whatever the case is. Guess what's happening? That's a secession. It's a session that is broadcasting that signal somewhere and allowing you to watch that. That is TCP. That's one of the oldest things that you could utilize, which is how the network layer was built. So that's your session layer. That's layer number 4. So basically, at the end of the day, it creates a session, allows these, in this case, multiple devices to communicate with one another, and has a handshake process into place and builds the session. Okay, so let's move on. Then we have the application layer. So this is when you're, like, I'm using Pluralsight, for example. If you're going to call a website like jeffreyjseaman.com, or in this case, Pluralsight.com, you're going to have to return something. So we're doing that whole process. Client connects to the we'll just say Wi-Fi network, whatever the case is. Then it hits the wireless, the router, the local router, cable modem router, hits the internet, communicates to the web server, in this case, pulls back the website. So all that is called Hypertext Protocol, HTTP. So if we're so used to entering www in, but if you look at the beginning header, you'll see HTTP, then you'll see HTTPS. HTTP is if you see HTTP and you're doing some type of transmission, that means it's unsecured. S means it's secure, so it's more safe. And that is basically you're transferring. What we're doing here is we're transferring documents such as text, videos, images, etc. Using a language called Hypertext Markup Language, HTML. It's been out for a long time, and it probably is not going anywhere. So that's how it allows us to communicate, by utilizing that. Now, if you notice here, we skipped layer 6 and layer 7. And the reason we skipped those layers are because those layers are not needed anymore. So when this OSI model came out, this came out before even you and I were born, in the early 1970s. And this model was something that they used at the time, but we don't use anymore. So for example, the presentation layer, we don't use this at all. It came out in the early 70s. It was an open source that universities use, so like us, and IBM had their own protocols similar, which was proprietary. So the two didn't kind of mesh together. So if we inputted a message like "don't jump," D would equal 44, O would equal 6F, and N would equal 6E. And then the output would be that. If we did it in IBM, it would be completely different. So they used a different presentation layer. So that's why we're in a different format where we're all using the same environment. So we're using think of it as this network layer that we're utilizing. We're all using the same thing. So it's not like it's something different. Okay. So we're using what's called, in this case, going back here, don't jump. In this information, they were using the American Standard Code for Information, ASCII. So you'll see that around. Where IBM was using called that, I probably can't pronounce it, EBCDIC, which is EBCDIC, which is converted differently because it was based off of proprietary public or private information. Okay. The other one was the session layer. So this is also a layer that is no longer needed. So we skip those levels and we just go into the other levels that we need. So if you look at, we're talking about the OSI model encapsulation, but going back to the model here, we use the application level. We don't use presentation session. We use transport as how information is transported. We use the network, the data link, and the physical layer. Those will all be on a quiz this week too as well. So just an FYI. Just throwing that out there. So when you are utilizing the application layer, so now what we're going to do here is we're going to actually encapsulate this, how this actually would work, just to kind of specify, when we talked about communication process, how the phone communicates. And now what we're doing here is we're actually talking about how this works from utilizing all the layers. Okay, so we have the application layer here, which is I'm breaking down that website that I have, Jeffrey J. Seaman, and it is breaking those pieces into small pieces. So it breaks the images up, or well, let's say images, the website into small packets. Think of them as data packets. So this is going to work with the transport layer. Okay, so let's hit next. So transport layer is broken down into small sectors. We have the source port. These are port numbers, and we'll talk about these in other modules as well. We have the destination port, flags, sequence number, acknowledge number, and payload. So when we're thinking about this, we're taking the data and we're breaking it into small chunks of data. And that's what we did on this slide right here. We're taking this and putting it into smaller chunks. And we're taking it and moving the payload header, which is the end here, piece by piece. So we're setting up a session between our client and server. So, the client is a guy on a computer and the server is over here, right? The other parts are the flags, the sequence number, and acknowledge number. It allows us to capture and collect how much data is transmitted and being received. So think of it as data analysis. We're collecting the data and we're utilizing this to understand. So if you've ever gone, like, I don't know if your parents or you look at your internet bill for the month and you see how much data you transmitted. Well, here's for example, if you have a smartphone and you're not on an unlimited plan, you'll see, hey, you know what? So-and-so use X amount of megabytes per second. Well, that's what's happening when you're communicating with the web. Is this transport layer is capturing that information and recording that information, recording how much bandwidth that you're utilizing, how much space are you utilizing. So think of it, the transport layer, as this that's happening right now. Okay. So, so you used to ask if anyone have any questions. All right. So that's the transport layer, as I mentioned. So, for example, go back to the transport layer for a second here. So think of this as you're sending out a Christmas card, right, to friends or family members, and you write on a card. So you write, whatever you want to write on a card, and you put in an envelope. You seal it up. You put on the sender's name on the envelope. You address information, return address on the envelope, normal stuff. So the envelope think of it as a transport layer, and we'll say it's this segment. Any data on there, so anything that you're writing on the letter, on the envelope, anything you're writing inside of it is the header at the transport layer, and it is the segment. So the header is the TCP header. Allows the client and server to set up a session that allows us to keep track of what was sent and received. So you send an email. Sally sends an email to Bob, and it records the session information. Header in this case will probably be who's it from, who's it to, what's the subject line, and what's the body. Those will all be part of the payload, and that will be your segment. All right, let's talk about the network layer, okay, a little bit. So we talked a little bit about transport and how this process works. Network layer, very similar. Source IP address, destination IP address, TTL, other, and payload. So in order to know where to send it at, we need to know the destination IP address. In this case, going back to the letter, we need to know where Bob lives at. So his physical address, 1313 Mockingbird Lane. Where on the internet or network, where's the client located at? We could take the segment of the transport layer and the source, destination, of ports, flag, sequence, etc., and put the payload into our networking payload. So if we go to this next slide here, we could take all that information that we got back from this slide here that we captured, and we can put it in here. So we can put it in our network layer, which will allow us to provide that information in the header. So it could be the packet. It could be anytime we could have data with the network header. We could have the IP header, like version 4, version 6, chunks of data, what network layer, allowing us to know what endpoints to send to. Then we go on over to, yeah. And that's giving you what I said here. So this is the chunks of data it's sending over. We have the data link layer. So what's the data link layer? We can now send our network layered pack to data link, put the data into the frame. Frame is a chunk of data with data link layer header. In this case, it could be the Ethernet. So it could be the Ethernet information. So when we're transporting Ethernet, it's transporting what? The packets of data that's being passed over. So it gets sent in the physical layer. So all the address information, protocols that we need for the physical layer, it converts to ones and zeros, converts into a signal, which can be a light signal, so fiber optics. So it's going across fiber optics. It could be electric signal that sends across a copper wire, or it might even be an electromagnetic signal that we use in a wireless. So every time you're visiting a website on your phone, tablet, computer, wherever, all these layers are involved every time. So at this point, does anyone have any questions? Obviously, this is a recorded video. So if you do have questions, reach out to me. I hope you enjoyed the first module. Each of the modules will be like this, where I'll do a lecture instead of sending you guys slides. I don't think that's appropriate. I want to provide you the best experience. So thanks for watching, and have a good week. Bye.